Hello everyone, this is Dr. Dzak, and today as we begin Unit 9, we're going to discuss the area of a region trapped between two curves. Just a reminder that you may use a calculator for this problem set whenever you need to. As you begin today's lesson preview, you should have drawn the graph of the tangent of x. Notice where it's trapped. We are trapped with y equals 0, as well as x equals 0, and x equals pi over 4. So we have this region. It's not quite a triangle. To determine the area, you need to write the area is the integral from 0 to your pi over 4. Those are x values. Tangent x, everything's great, and we're going to cut on the x-axis. Now, you've integrated this one often enough to know that you should end up with negative natural log absolute value of cosine of x between our 0 and pi over 4, which leaves us with 1/2 natural log of 2. Now, as we think about this, the f of x denoted the height of your rectangle, and delta x was the width of the rectangle. And if we use Riemann sums, we're going to add up all of the areas of the rectangles in order to get the area formula. When you looked at question B, it was a similar problem, but we moved one of the boundaries. Y equals -1 became a boundary, and when you drew that in, there we go, x was still equal to 0 as a boundary, and x was equal to pi over 4. So this region, we'll call this region 1, is going to have the same area that we had before, but we now have this new region, region 2, in which we're going to add the area. So region 1 plus region 2, you should come up with 1/2 natural log of 2 plus pi over 4 when you recognize that that is just a rectangle with a length of pi over 4 and a height of 1. All right, but think about for a minute how we would follow the similar ideas. If I draw my rectangle, there we go, from the red line all the way to that blue line, notice the height of the rectangle is no longer f of x. Matter of fact, it's bigger than f of x. It would be f of x, and then we have to go all the way to y equals -1. So how do we find that? The height of our rectangle is equal to f of x minus -1, or f of x plus 1 in this problem. So if I want to write an antiderivative, that's going to be the integral for f of x plus 1. So that'll be tangent of x plus 1 multiplied by the width of that rectangle, which is still dx. And I'm still going to integrate from 0 to pi over 4, because all of these rectangles that I draw, thinking of Riemann sums, will be trapped between 0 and pi over 4. So instead of using f of x, we're using a height to find the area. So the area trapped between two curves is going to be from A to B of the h of x for height multiplied by d of x when we're cutting on the x-axis. So that lesson preview sets us up for our first example. So for example 1, we're going to find the area of the region bounded by y equals 2 to the x plus 2, y equals -x, x equals 0, and x equals 1. So those are 4 sides of a figure. Let's find out where they are. When you graph, when x is 0, you're going to get a value of 3. And if you were to continue, you should know that 2 to the x plus 2 is going to look like that red function that we had. When y equals -x, that of course is also a function that you should know what it looks like. There we go. X equals 0. So x equals 0 is going to be the y-axis. There's your x equals 0. And then x equals 1 is a vertical line, of course, at 1. Now we want the region that is trapped between all of these values. I'm going to gently shade that in. It is this region. There we go. Now, as we think about the region, we need the height of that function. I want to cut on the x-axis if I could. I'm going to draw my height. It would be the top function minus the bottom function. So if I think of f of x as the top, and this is g of x for the bottom, the height of my rectangle is going to be 2 to the x plus 2 minus negative x. So the height of my rectangle is going to be 2 to the x plus 2. So the area, which is equal to the integral. Now we're going to integrate with respect to x's. Look at your x values. The smallest x value is 0. The largest x value is 1. The height with respect to x, we're going to write in, and then we're cutting on the x-axis dx. So this is the integral from 0 to 1, 2 to the x plus 2 plus x. And remember, minus a negative is positive, then we'll have dx. Now it's time to integrate. Do you remember the antiderivative of 2 to the x? That's why I chose this one. It's 2 to the x divided by the natural log of 2 plus 2x plus your x squared divided by 2, and we're going to evaluate from 0 to 1. Please be reminded that you shouldn't use your calculator unless it is necessary. All right, substitute your 1 in, and you are finished. So what is the height of the rectangle with the width dx? Your height is going to be 2 to the x plus 2 minus negative x. So still using the concept of Riemann sums, but we're making it a little bit more challenging. Looking at example 2. Now, I am not going to give you the graphs on a test. You are going to have to draw them. So practice drawing them on your own. We have f of x is 2 minus x squared. That is an upside down parabola with a vertex at 2. And when we draw that, we will have a nice little graph here. And I want the region bounded by the graph, g of x equals x. And let's see here. So the region, I'm going to gently shade what we're looking at. I'd like you to get used to drawing and shading, please. Next, I'd like to draw the height. So if you want to represent the height of the graph, use a color to represent. I'm going to use purple to represent the height of my graph. Now, look at where I draw it. Does it matter? As long as the height is the same all the way across, we are set. Notice it is my f of x is that top value. G of x is the bottom value for each one of these. So the height with respect to x is going to be f of x minus g of x. And in this case, we now know that the area is the integral, oh no, I don't have my endpoints. Get them in a minute. Of f of x, which is the quantity 2 minus x squared, minus g of x, which is x. We are cutting on the x-axis. We know that because the lines we're drawing are perpendicular to the x-axis. Endpoints. We're going to have to take 2 minus x squared, set it equal to x, and solve it. So we will have x squared plus x plus 2 is, minus 2 is going to be equal to 0. So we have x plus 2 times x minus 1 is 0, which tells us our endpoints are at negative 2 and 1. Integrate your problem. Once again, as I said, only use a calculator if the problem indicates you need a calculator. And we will have a minus x squared over 2 from negative 2 to 1. Now recall, when you are taking your test, the AP exam does not require you to simplify all the way. I do require you to simplify. I know that's not fair, but I want you to get into the practice of good arithmetic because that is a skill that you would need. So if you were taking the AP exam, you could leave your answer just like this, or you could simplify it and get a 4.5. So what is the height of the rectangle with width d of x? Once again, that would be h of x equals 2 minus x squared minus x. All right, everyone, for example 3, you are now expected to be able to graph a sideways parabola with a vertex at 3, 0. It's going to have some intersection points at 0, negative root 3, and 0, positive root 3. If you have trouble graphing the line x equals y plus 1, remember you can just solve it for y. So y equals your x minus 1, and the graph is a lot easier. As you can see, we are looking for the region trapped between the red curve and the blue line. Now let's talk about the height of our graph. So I'm going to use a rectangle to represent the height, and draw one for us. We have a nice little rectangle here. And if I were to take the height of this rectangle and move it, notice I've got a red line minus a red line. And if I move it a little bit more, now it's blue minus red. So the area, if we're using top minus bottom, is going to take 2 integrals to set up, and that is annoying. So we'd like to come up with some other way to do it. Let's take our line, instead of drawing the rectangle top minus bottom, let's go across. This time we're going to do right minus left. Notice the right side of my rectangle is on the red graph, and the left side is on the blue. And as my rectangle moves, notice it's red on the right, blue on the left for the entire figure. So we're going to use right minus left to find the height of the rectangle. And what that does for us is the height is now going to be with respect to y. And the right curve is 3 minus y squared, that's the red one, and the blue curve is negative, so it's minus y plus 1. That also means that the area equation needs to change. We're going to integrate using y values. We're going to have a height with respect to y, and notice that purple line is cutting the y-axis. So put it all together, and what we're going to get is that your area equals, we need endpoints, find those in a moment, and then you have 3 minus y squared minus y minus 1, and then you'll have a dy. Now what are those endpoints? We want to know, where does 3 minus y squared equal y plus 1? Set your function equal to 0, and you will notice that you will get negative 2 and 1 as your y values. And once you solve it, so we're going to go from negative 2 to 1 to integrate that function. And once we integrate, what we end up with is, once again, 4.5. So at times, it's important to change the height. Think of your rectangles going from right minus left instead of top minus bottom. It really depends on which functions you're using. So for example 4, we're finding the area of the region between the graphs of f of x, which is your cubic, and g of x, which is your quadratic. Now, when you graph this on your calculator, you have to be very careful to be looking at the full graph. As you can see, there's more than one region for which these are intersecting. And if we think about those rectangles again, let's draw a rectangle to help us figure out what's happening here. If I do a right minus left, the green region's very complex. I've got red minus red. As I go upward, notice that red, this is very complex if I do right minus left. So I should probably not use right minus left. Perhaps if I draw the rectangle as top minus bottom, that'll make more sense. For the first region, it's going to be the red curve minus my purple curve. For the second region, it's the purple curve minus the red curve. So you actually have 2 different heights in this problem, which means you're going to need 2 different integrands. All right, so let's write what that means. There's a couple ways to do it. First, we're going to write area equals the integral. I'll come up with my endpoints in a moment, of f of x minus g of x and dx plus, and we want the integral We want to do g of x first because that one's on top. So g of x minus f of x dx. All right, next we want to figure out where do these things intersect. So you take your 2x cubed minus x squared minus 10x. You set it equal to negative x squared plus 2x and figure out where these lines, these curves intersect. What you will find is that you will have 0. I think that one should be obvious. You will have x equals root 6 and you will have x equals negative root 6. So think about where we're going to integrate. We're going to start from negative root 6 and go to 0. Then we're going to go from 0 to positive root 6. These are not symmetrical, so you're actually going to have to do this integration separately for each part. Now, once you finish, you're going to take the area from region 1 and add it to the area of region 2. And both of these, even though they don't look the same, come out to be 18, and 18 plus 18 is 36. All right, now I want you to think about what just happened here. We took the region f of x minus g of x and added the answer that we get for g of x minus f of x. What if we wrote the area is equal to the integral from negative root 6 to root 6, and instead of worrying about which values are positive and negative, what if we used an absolute value around that difference? What would happen is the red line would get switched up top and your area would become a positive region. Your blue line gets switched down bottom. The region that you get because of the absolute value would be equivalent to setting up two separate problems. So this problem, very cool in that you have multiple ways to set it up. Okay, so let's put it all together. If your height is perpendicular to the x-axis, your area is going to be the height multiplied by your delta x. If your height is perpendicular to the y-axis, your height has to be with respect to y. Now, I like to use right minus left when I'm thinking about the y values and top minus bottom when I'm thinking about x values. The width is that rectangle you've been drawing. The width of the rectangles will be delta x or delta y. All right, so now I want you to set a timer and work on the following problems for about 30 minutes. Don't work longer than 30 minutes. You will get more practice at the end. So turn off the video. Once you're finished, you can check through a couple of your answers. Make certain that you have found h of x correctly and that you are able to integrate without a calculator. And for question 2, be certain that you're able to graph the two equations correctly, integrate, and set up your problem. Just a reminder, I would expect you to use a calculator for numbers 3 and number 4. So as you set up question number 3, did you recognize that you had two regions to think about? And rather than doing a top minus bottom, integrating from -1 to 0, and a different top minus bottom from 0 to 1, just use that absolute value function within your calculator. For question number 2, you have a nice little ellipse to think about. So I'm going to just use properties of symmetry and think about multiplying this answer by 2. So I'll have 2 times that region after I've solved for y. Once again, use a calculator in order to integrate. As you give 35 and 36 a chance, remember number 36 is going to integrate using u sub, and eventually you will have a natural log. Question 40, be certain to figure out which function is on top. 41, same problem. Actually, no, this one's a u sub problem. And for 42, you know that 3 halves x plus 1 is on top. So top minus bottom, you can integrate using your calculator once again. So let's take a look at the trapezoidal rule. Remember, the area of a trapezoid is 1/2 the base multiplied by your delta x. In this problem, delta x was given to you as 4 miles. Make certain that your final answer is in miles squared. When we look at question number 66, this was a really fun little problem. You had to write the equation of the tangent line, which brings you back to derivatives. Then you needed to know where your two lines intersected in order to find your endpoints. Once again, top minus bottom, and use the calculator to integrate. All right, so I'm sure you noticed that question number 67 was a fabulous little problem. Find the area of region 1 and set it equal to the area of region 2 using B as the endpoints. Once you solve that equation, you will find the value for B. For your homework, look at page 442. Notice you have asterisks by questions 35 and 49. Give them a try, but do not get stressed out if you find them challenging. That's it for today's lesson, and you have a wonderful day.